This is the MRO current sensing board, power distribution board. It does a lot of things. It comes with this little 220 microfarad 63 volt capacitor, and that should be soldered across the battery lugs, something like this. And what that's for is, I don't know if you've ever plugged in a battery and had a little electrical arc, little pop, a little bit of electricity as you plug it in. And that happens more with 6S and above batteries. It can happen with all of them, of course. This capacitor, we solder it across in parallel with the input voltage, and that cuts out the little arc when they're brought near each other. This capacitor charges. There is a little bit of current flow after you disconnect it for a few milliseconds, but other than that, this just absorbs that and keeps that spark from happening in here when you plug it together. So I'm just going to solder that on. You can see the upper is the battery plus, lower is the battery minus. On a capacitor, diode, whatever, we know that those of us that have worked with this for years, know that the long leg on a capacitor or diode is the positive leg. Another way to know is, if you look at this leg, you'll see there's a minus symbol. If this will focus, trust me, there is. So the negative leg is marked with this stripe. The positive leg is really not marked in any way except for being longer. But it doesn't take long to understand that the long leg is a positive. So I'm just going to basically solder it across like that. Don't want to get it too close to the board so that the bottom of the metal can shorts on anything that could possibly be here. So just an 1/8 or a 1/16 of an inch out from the board. Just going to solder it straight across there to keep it where I want it while I'm soldering. I'm going to try to put this alligator clip on here. Whoops. And hope that well, I guess I can't do that. Well, I was going to try, maybe we can go in right here. Just barely. Nope. Well, I know where there's another clamp. This one doesn't have any alligator teeth in it, so something like that. Let's see what I can get going here. Normally I use this for a heat sink. Okay, nope. That is, wow. Oh well, I guess I'll just have to do it the old-fashioned way and try to hold it. But that's what I will be doing, is soldering it right in there like that. Let me do this off camera. So I tacked one side down just a little bit, and I'll try to get the other side now. No, that is not my finger at the bottom. I do have a helper. And the only thing I'm trying to do here is tack this side down.
I had to fix that in another way. That got hot on my wife's finger.
So now with the help of a helper, I've got it tacked. I'm going to go back and add a little solder to it now. Come on. There we go. Take that away. And I'm going to add a little solder to this one. Well, this is hard to do. I need some kind of holder for the board. Okay. There we go. Take the heat away last. Let that cool a second. Ouch. Boy, that transmits the heat all the way through that board. I'm not sure why. But anyway, there's the capacitor soldered onto the board. We'll take a pair of side cutters and cut this excess, still quite hot, leads off. There we go. So that should be it. Do a little cleanup on that later. Look at this one a little closer. That don't look as shiny as I want that negative to be. Look at it with a magnifying glass. I'm pretty sure it would be electrically okay, but I like it to be a little shinier. So I'm just going to touch it again with the soldering iron. Try to melt it all. And then move away again. Let it set up. Sometimes when it's still a little molten, if something, ouch, moves, then it'll turn gray. Not as shiny, not silver shiny, just kind of dull. And that's a good indication of a cold solder joint. But one more little change there. I need to get a solder helper. So this lead is kind of on the top of the puddle. So I'm going to use a solder helper here just to make that side molten again and push this leg down so that it's inside the whole puddle. That's just strange. Hold everything real still with both hands there. Now that looks better. That's a real shiny solder joint too. If they turn kind of dull like a coin, a nickel, even though it's supposed to be silver. And as you can see, checking for heat, as you can see, there was the first time the lead just wasn't inside the solder pool puddle, it was on top of it. So now both of those are nice and shiny and I like those. So that's exactly what I want. Trim back that excess as far as I can. And that should be finished. That should work well. That's the current sensing board and basically a little power distribution board to the ESCs from MRO Robotics. Good company. Let's see if I can get that. Oh well. It's not going to hurt a thing. I'm just a perfectionist. There we go. So now that lead has been cut off, I'm just going to use the end of this solder helper to rub some of the flux off there. Just a little cleanup. Oh, I got a toothbrush around here someplace too. So that should do it. Don't know what else to say about this part. So I was going to get the electronics ready for the little mini Talon. So tonight I took all the parts out of the box for the Autopilot and started working with them and getting them working the way I want them to. And that's why I took the little current sensing board out of the shipment. And like I say, this cap comes unsoldered. And if you want to, you can solder it on. It doesn't hurt a thing on the lower cell batteries like a 2, 3, or 4 cell LiPo battery. It's just usually the 6 cells and above you'll have that pop. Sometimes on 4 cells, and of course sometimes on all of them. It just depends on what happens. So if I've done everything right, sorted it to the correct polarity, everything, I should just plug this right in here. This also supplies power to the MRO Autopilot. And here it comes. We're either going to have success or smoke. And capacitors can pop like a firecracker too. Here we go. Ah, we have lights. Lights on the power distribution current sensing board. Lights on the Autopilot. And we have lights on the GPS compass. This is a 915 megahertz telemetry transmitter, and this little 900 megahertz antenna that's plugged into the flight controller, Autopilot flight controller, whatever you call it. Got a green light there now. Gee, let's go over to Autopilot and see if we have any kind of activity there. So now I'll come on the other side of the room where my computer is at the workbench, and we'll load up Autopilot and check our COM port for, we'll have a little telemetry radio on the computer right now. 57600 connect. If everything's good. Ah, there we go. So we're actually reading in the perimeters from the Autopilot that's 10 feet away, 15 feet away. I have two 4x8 sheets of plywood on 4 file cabinets. That's my workbench. So my workbench is 4 feet by 16. It's 12 feet away. And there it is. Got 10 satellites locked up at this moment on the GPS. And it's homed right in. And it's darn well locked on the actual location of that GPS. This is the back of the house, and that is the other side of my table. And you see I brag on it and it starts drifting a little bit, but that's normal. It's not moving. When it's moving and the GPS points are being updated, the calculations are much more pure. Right now, 1 second it thinks it's going one way, next second it thinks it's going the other way. If you're using those figures mathematically as a kind of a bias, not a direct read, but to slightly modify another value, well, they're changing into just numbers that conflict. If it's an airplane, it's not going to be going backwards like it is right now. So that's why that happens, this little drift. Even with now, you can see over here 11 sats hooked up.
So, gee, so far everything seems good. I have a power distribution slash current sensing board that I installed a cap on, capacitor. There we go. And oh, come on, quit that. I hate those nags. Where we at? Here we go. Okay, this is the Autopilot we're talking about. MRO X 2.1 Rev 2 Autopilot. You can get them with pin headers already on there, soldered on, or they will send them if you want it for your own do-it-yourself soldering, right angle or straight. I got the developer's kit. I did get this GPS along with it for an additional $54. Let's see, and what was that? This was 99 bucks for this little Autopilot. It's quite good for the price. And let's see, where is my power distribution board I was telling you about? Yeah, whoops. Sensors, power. Here it is. It's a UAV, that's the company that makes it, power module for up to 10 cell lipos. It has 5 volt or 12 volt outputs on it, in addition to having a lead on it to go over to the MRO Autopilot. They're showing the back side. I need the other side. XT60 loose or XT60 pre-sorted. I got the pre-sorted one, but that's the little power distribution board I soldered the capacitor on. Ultra low noise power supply with current and voltage sensing with power distribution layout. Takes up to 42 volt input, can sense up to 90 amp current. The 12 volt output, 3 amps max through that, a 5 volt, 3 amps max through that, and then it tells us the dimensions of the board. Now also to that Autopilot, I have connected sensors. This, make sure this is the right one. Nope, this is the right one. That's Wi-Fi. Okay, this little telemetry radio that I bought in the 915 megahertz value is what I also have hooked to that board right now. And last but not least, what we've already got going. Got to go back and get the number, which it is M8N. Let's see if I can get that up for you. I think this is, no, that's the M9. Here we go. Here's the M8N compass slash GPS, which you see over there. It really does do a very, very good job. Locks up fast. So that's what you see over there. And again, we can see that. Oops. Log out. Now we're down to 7. Well, just jump back up to 8 GPS satellites locked up, which won't be as accurate. That's why it's running around the top of the house again. But there's that. That's what I've kind of played with for a few hours tonight. I had to get all that stuff out, figure out which port. I've never worked with one of these autopilots before. Worked with Autopilot a lot, hundreds of hours. But that's the first of the MRO 2.1 autopilots I've worked with. So I had to get the GPS connected, the telemetry radio connected, the power distribution board connected. Did do the cap on the power distribution board. Off camera, I did flash the autopilot to the current version. That was just came out in the past couple of days too. Ardu Plane 4.0.8 is the version I flashed onto that autopilot. It's going to be used in the mini Talon. So what else? I haven't hooked up the compass or worked with the compass yet. I put my Nano Talon perimeters into the autopilot just to get some default perimeters in there that would let me work with it. So that's about all I'm going to do today. I'm happy that my soldering came out okay and I didn't blow anything up. So doesn't seem like much, but actually there was 3 or 4 hours spent tonight getting all this running to this point, and I will pick it up again on another day.
And some of the other stuff I did today, I dry fitted this carbon fiber spar down the length of both halves of the mini Talon fuselage. I'll be gluing those in. I also basically dry fitted the carbon fiber rods in both vertical tails, and also the servos I sort of dry fitted. Now, got some little problems. The rod's a little longer, the channel that they've got, so I may push it up in there a little more. It doesn't want to go much further by itself, but I'll try to get this in flush after I dry fit it in the fuselage. I'll see what if it causes any problems the way it is. The servos do have a problem. You can see there's really no room right here for the horn to go on, and if you look, let me pop this out. If you look, the holes for the ears on the servo, they're a little bigger right now than they were because I kind of had to force that in there, because I'm going to have to shave some of the bottom where my thumb is right here off to bring that servo down a little. It's not a big deal. You can see it on the other one here. Again, I put the carbon fiber rod in it, and again it sticks out the bottom a little. I'm not sure if that's going to be a problem or not. I can just make the channel bigger if I want to flush it up down here. But again, you can see how the servos really, you can see how it's pushed up I'm going to bring it back down that 1/16 of an inch by cutting this, and then that'll make my area where my servo horn's going to be a little, give it a little more space there. You don't want it binding or anything. And this is where the servo horn will be glued on. I also did the same thing with the servos for the ailerons in the wing on both sides. They're just dry fitted, and they have exactly the same problem. These 4 servos are all the same, so they're physically the same size. So all the servo bays are going to have a little foam removed down here. Not much, 1/16 of an inch, just to pull those ears down this direction a little bit, and that'll give me room up here for the servo horn. I did also there's 4 carbon fiber spars for the wing. There's 2 small ones that go out all the way to where my thumb is. They kind of are screwed down right here by a little clamp, and then this one is a separate one that just goes from right here to right here. That some of this spar out here is actually inside this one right in here. So there's actually 1, 2 carbon fiber spars, and then a 3rd one in the center that all screws down on these 2 little cap things inside the wing. And then in the back of the wing there's a 4th carbon fiber spar that goes from, you can see it a little bit through the wing here, it goes from here all the way to here in the back of the wing. And that's how that whole wing goes together. And that's what the whole thing looks like. So that was also some of the stuff I did today before I pulled out the Autopilot. So I have to get those 4 servos bays notched out a little bit for the 2 wing halves, for the 2 tail pieces. Figure out what I'm going to do with the end of this spar on each of these. Might not be a problem the way it is. I'll just have to stick them down in the fuselage and see what it all looks like. And then I have to do the servo horns here, do the linkage between the servo and the control surface. Same thing over here, control horn here, linkage up to the servo for that aileron. Glue in these carbon fiber spars. That basically gets the frame of the airplane ready to go together before I glue the 2 halves of the fuselage together. I'm going to be doing a lot more pre-planning multiple times, so I'm sure of what I want, and get everything right before I put any glue on the 2 halves of that fuselage, which is why I started laying out the Autopilot. I'm going to have to see how it lays out against this frame, what leads I'm going to have to lengthen, etc., etc., etc. So I pulled the Autopilot out. I'll be laying it all out on the cutting board and getting all my connections to length. Then I'll be checking it again against how I'm going to put it in the frame. Probably do that 2 or 3 times before I do any gluing. When I know that that's all close, I will glue the two frame halves together, and then we'll start putting the electronics into it. And it's just a matter of putting the wings on, motor on, all that. So there's a little bit more than was apparent there at first. Had been sort of done today. 3, 4, 5, 6 hours just piddling around. Fun time.